We have a beautiful question on the board, and so this is the part 2 of the video on thermodynamics. Endeavor towards the part 1 is on our channel. And so we have a question, say calculate the change in the internal energy of a system if 300 joules of heat energy is added to it, and if the system performs 200 joules of work. Now, on the part 1 of the video, I've already introduced two formulas. If you understand, you can use any of it and you get the same answer. So, for the sake of time, I'm going to continue using this formula. Change in U is equals to Q minus W. You can use that of the chemistry point of view, that of the physics point of view. I'll show you get the same answer. And so, remember we said that this is internal energy, that this is heat, and this is what? Work. And then they say we should calculate the change in the internal energy. So, change in U is what we're asked to find. If 300 joules of heat energy is added to it, please remember something. Whenever heat is added to a system, we're talking about an endothermic reaction, and that means that our Q is positive. Whenever heat is released from the system, that means we're talking about an exothermic reaction. And what it simply means is that our Q is negative. And so from this question, you will now see that they say heat is, if 300 joules of heat, that means our Q here is plus 300 joules is added to it, and if the system performs 200 joules of work. Now, is it work done on the system or work done by the system? Remember our principle of Bohr under the part 1, we said work done by the system is positive and work done on the system is negative. And so you can see that if the system performs 300 joules of work, it means that work is done by the system. And if work is done by the system, it means that our W here is what? Plus 200 joules. So all you need to do right now is you start using this formula and the answer will flow naturally. And so we already have that change in U is equals to Q minus W. And then Q is 300 minus, and our W is 200. So this is 200. And our answer is simply what? 100 joules of energy. This is so how easy this thing can be. Remember our simple formula Bohr, which is work done by the system is positive, work done on the system is negative, and this is our formula. If you are using this formula, please. So endeavor to watch my part 1 to correspond the whole thing I'm doing in this video. Let me solve more examples. We are into example number 2, and so you can see, determine the change in the internal energy of a system if 700 joules of heat energy were removed from it, and if 400 joules of work was done by the system. And so we have our beautiful formula, change in U is equals to Q minus W. Remember our simple formula Bohr, work done by the system positive, work done on the system negative. And so determine the change in the internal energy if 700 joules of heat were removed, so heat was released. And so we said if heat released, the heat energy is negative, so we have negative 700 joules. Now, from it, and if 400 joules of work was done by the system. Remember, if work is done by the system, if 400 joules of work was done by the system, and so remember from if 400 of work was done by the system, so work done by the system, W here is what? Plus 400. So putting it into this formula, we have minus 700 minus 400. That should give you minus 1000 joules. Now, this is the change in internal energy. What if I come here, I change this, and I say work done, and work was done by the system, and I'll say on I will change this and put on the system. So you can see this will now be change in U is equals to Q minus W, and this is your Q will now be minus 700, and then your W will now be minus, because work done on the system will now be minus 400. Now insert it into this formula, you have minus 700, we have minus in the formula already, minus 400, right? So you have minus 700, minus times minus will give you plus. You have plus 400, and that will give you minus 300 joules. So please note the difference. Now, using the other formula from the part 1 of the video, please try to solve it and confirm the answer. Drop your observation on the comment section. That is all for this video. Thank you very much.